$20 to spend on games and rides at a carnival. Games cost $1 each and rides cost $2 each. Table 1. Which of these equations represent the relationship between the number of games X and the number of rides Y that Jada could do if she spent all of her money? And Y equation C. Okay, so I'm gonna pause you right there. So Y class tells me what about the situation? Just the Y alone? What about the rights? Sorry, I didn't hear that. Brayden, what did you say? So the Y alone doesn't tell me that they're $2 each. The Y is, what about the rides? How many rides you go on? So like the number of rides. The $2 is how much those rides cost. And it gave you that information here. Rides are $2 each. It told you it wanted you to use Y for rides. Would they specify that? Make sure that you do that. Okay. And depending on how many rides I go on, I would have to times that by 2 because if I go on 2 rides, it's costing me $4. If I go on 10 rides, it's costing me $20. Like that's multiplication, right? None of the other equations add that shown that each ride is $2. So just based off that alone, this one must be it. Each of them are equal to 20. What is the 20 representing in the situation? How much money she has in total. So in other words, her budget. But remember how I told you before, like totals are usually alone on one side? That's why, because that's the total amount of money she has, her total budget. On the other side is what's contributing to that budget. So like, if we're talking about money, the other side probably has money involved too, and it does. Table 2, can you tell me what the X represents in this situation? The number of games she plays, good. So number of games she plays. Class, why doesn't this one have a number in front? Because it only costs $1. So if she plays 2 games, it's costing her $2. I'm essentially multiplying it by 1, but anything times 1 is just that other number, right? So when you see that there's no number in front of the variable, what is that number? A 1. That's a really important thing you need to know. Did you hear me? All of you that are kind of tuned out. If the number is not written in front of the variable, what number is it? 1. A 1. Okay. So know that. That's why this one is correct. Now you also have to look at the ones that are incorrect and say what they are basically saying about the situation. So table 3, I'm gonna ask you, let's let me scroll a little bit. Table 3, can you tell me what equation A says about the situation? You guys. Table 3, are we paying attention? That's you guys. What does equation A say about the situation? That both the games and rides cost $1 each. So you could say both games and rides are $1 each. It's lagging, so hopefully you're paying it. Because what are both of the coefficients in this one? What's the number in front of the variable for both of these? 1. So coefficient, by the way, is the number in front of the variable. That way you know what you're talking about. It's not written, it's 1. So for equation A, that's saying that both the games and rides are $1 each, which is not correct for this situation. Table 4. What is equation B saying about the situation? Okay, great. So games cost $2, rides cost $1. So if you thought this one was the correct answer for the first part of the warm-up, then you just need to go back and read what the variables are representing. It tells you on almost every single word problem, it tells you what the variable represents. So you have to match it up correctly. Good warm-up. Reason why we want you to understand that is because you are each gonna have, I mean, there's 3 different equations total, but each of you are going to be assigned a certain equation similar to this. So games will still be X, Y will still be rides. And you are going to answer these 7 questions about your given equation. So the equation is in the pink basket, it's on an index card. And then I need at least one person from each group to get into the pair deck that I'm gonna put on the screen. For your note-taking purposes, that you are putting correct answers for your assigned equation. You don't need to write everyone's equation, just your own. Okay, but first, let's look at the people that had x plus y equals 20. So if you don't have that as your assigned equation, don't write down their stuff, okay? So x plus y equals 20. X represents what in this situation? Number of games. And the first question it asks you is if they don't get on any, or if they don't play any games. So if they don't play any games, what does X need to be? No. If X is games and they don't play any games, then X has to be 0. We know it costs $1 per game because of the way it's set up, but we want to know if they don't play any games, how many rides can they go on? And what is 0 plus Y? Anything plus 0 is just that other thing, right? And if Y is supposed to represent number of rides, then they can go on 20 rides. And then that would be marked here on the y-axis, as the y-axis is the number of rides. It would be at the 20 when they play 0 games. Okay, so at the y-axis, they play 0 games. So adjust that, whoever had this, you can delete your line and you can adjust it. But that would be this situation. Questions on that? Does it help you with whatever equation you had? If they play 0 games, then the X has to be 0. Now, if we want to figure out the number of games, so we want to figure out what X would have to be, so it's going to be X in the equation. And it's going to be when they don't get on any rides. What variable is for rides? Y. And if they don't get on any rides, what is Y having to be? And then you solve for X. So what's X plus 0?
X.
So this is right. They would play 20 games if they don't get on any rides. So they did mark that part right. When they go on 0 rides, they can play 20 games. And you connect the dot. Questions on that? All right. So that's one of the equations that was out there. Let's see a different equation. Don't delete just because I might like yours if it has mistakes because of the Okay, let's try this one. So one of the other equations out there was 250x plus y equals 15. So how much does this person have to spend? 15, right? Because we just interpreted how to read these, right? How much does it cost per game? How much does it cost per ride? $1. Now for this one, same concept. If they don't play any games, what needs to be 0? If they don't play any games, the x needs to be 0 because that's what the games is, right? It's on the x-axis. So I'm plugging in a 0 for the x and I'm solving for y. What's 250 times 0? What 0 plus y? And that one, I get that they can go on 15 rides if they don't play any game. Did they mark that right on the graph? Yeah, they have the y-axis as rides. Here's at 15. When they play 0 games, that looks good. Now, when they don't get on any rides, what do I need to plug in a 0 for? If they're not getting on any rides, how can I figure out the number of games? All of you should be able to answer this. I'm not asking you for the answer. I'm asking you if they don't get on any rides, how many rides did they get on? Okay, 0. Where does that 0 need to go in the equation?
The Y.
Where the y is. And then we can algebraically solve for the x. Which is the number of games. Oops, and the y is actually 15, the budget. 15. What's 250x plus 0? And then look at what's being done to the x and undo it by doing the opposite. So what's opposite of multiplying 250? And whatever you do on one side, do to the other. And when I put that in my calculator, and I know because I did it earlier, but I would put it in my calculator, I do get 6, which is what they marked. So 6 games they can play when they don't go on any rides and they connected it. Like this. Second. All right, now there was one more example out there, and even though it might not be your example, you should still be paying attention because I'm not making you write them all down. I just want you to see how the process is the same. Let's see, looking for good. X plus 4y equals 20. Okay, let's look at this one. So this is the last equation you could have had. And if they don't play any games, what needs to be 0? The x. Since we know that they're not playing any games, I'm going to plug in a 0 for the x, and then I'm going to solve for y. 0 plus 4y is
4Y.
opposite of multiplying by 4 is whatever you go on one side. And if you got for this one, y equals 7, that means they can go on 7 rides. That is marked right over here. And they play 0 games. So that's the most amount of rides they can go on. All right, now if I want to find instead the number of games they could play, if they don't get on any rides, what needs to be 0 this time? The y. So I'm gonna do x plus 4 times 0. Class was 4 times 0. X plus 0 is x. So that one was pretty easy to solve. That one says I could play 28 games when I go on 0 rides, and that is marked correctly. And they did draw a line, good job. Good, any questions? Now, what do we call the parts that we graph? Like when it touches the y-axis, all of yours touch the y-axis. What is that part of the graph called? This is review from middle school, sit up, pay attention, listen to my question. What do we call it, the part that touches the y-axis? We typically graph it first. Maybe it'll come to you later, but that's important. Side note, I never went over the learning target, so let's go over it right now, maybe then it'll come to you. Today we are investigating what graphs can tell us about the equations and the relationships they represent. This whole unit is linear equations and systems of linear equations. So we're now getting into like the linear and graphing part of it. Anyone know like the format for a linear equation? I haven't told you yet. But like from middle school, what's like the one formula you might know? Okay, yes, that's a linear equation. We're heading toward this. Today we are looking at our standard form of a linear equation. So that's our ax plus by equals c. That's like the type of equations you have in front of you today, where it's x plus y equals 20. 250x plus y equals 15 or whatever it was. Those are all in standard form because they are better in standard form for our real world equations. Maybe not so much for graphing. It's still possible to graph from standard form. And that is by doing what we did this right now. And plugging in a 0 for the x or y so that we can find our, do we remember what these are called now? I'm giving you both here, I'm connecting the dots for you. What is the b in y equals mx plus b? Okay, b is on the y-axis, it has a special name, we call it the, no.
Idiot.
Y-intercept, okay. So when it touches the y-axis, what is it called? All at once, when it touches the y-axis, what is it called? When it touches the x-axis, what is it called? Okay, so when you have equations in standard form, like what we've been looking at all day today, so this isn't slope-intercept form yet. But when you have it like this, the way that you can graph is by finding your x and y intercepts, just like how you graph today. The way you find that is plug in 0 for one of them, solve. Then plug in 0 for the other and solve. By definition, your y-intercept is when x is 0. So like this coordinate is 0, 7. X is 0. You guys remember coordinates, points, ordered pairs, whatever you want to call them? Well, whenever x is 0, that's your y-intercept. Your x-intercept by definition is whenever, repeat the sentence. See if you were listening, you'd be able to complete it. So let me say it again. Let me start over. By definition, your y-intercept is whenever x is 0. So then your x-intercept by definition is whenever, and that's what we did. In each of these, we plugged in 0 for x, found our y-intercept. We plugged in 0 for y, found our x-intercept. So you can graph from this form if you do that. Okay, questions on this? All right. We're gonna go to the next tear deck screen, which you're still working with the same equations. Just now you're doing 4 through 7. So you're completing the sentence. If the student played no games, they can get on blank rides. For every additional game the student plays X, the possible number of rides Y increases or decreases by blank. Complete that based on your equation. Then find the slope. Where does the graph intersect the vertical axis? Vertical axis is your y-axis. Rearrange and solve for y. And find any connections that you notice in your new equation and the graph you've already made. Okay. Gonna give you about 3 to 4 minutes, depending on how hard you work. If you look like you're working hard, I'll give you more time. If you look like you're just socializing, we're just gonna move on. That means the rest of you stop talking. Even if you're still working on yours, I need you to listen to this one. Because that's better than making you do 3 of each of sets of these 7 questions, right? Like, look at it. So for the equation 250x plus y equals 15, we already figured out part of this answer before. If they played no game, so when x was 0, we found out that they can get on 15 rides. This part is new, and if you struggled with this one, what you could have tried was like, well, if they played no games, what would be an additional game after that? Guys, I need you to like look at me and make eye contact. If they played no games, what's one more after no games? What you could have tried is plug in 1 for the x and solve for y in that case. What's 250 times 1? Okay, continuing to solve for y, how do I get the y alone? Guys, stop working on your own, stop talking. Like, we're watching this one, we need to learn from each of them. So when we play one game, the amount of rides you can go on decreases by 250. Now, can you really go on 12.5 rides? No, but it's decreasing each time by 250. All right. And I can test that by plugging in numbers and seeing for myself. You should be able to see it with your graph too, but unless it's like a perfectly like straight line, it might be hard to. Okay. For this one, remind me what the y-intercept was. We did that in the last one. Was it 15? And then what was the x-intercept? Right, tremendously. Okay. So you can, whoever's this is, you can use a line tool to make a perfectly straight line. But what I'm seeing is that the line is still like too thick to really calculate the slope from that. It is possible to calculate slope from a graph. Like, what is the formula for slope? So just slope, just the m would be like your slope. But how do I find slope on a graph? Rise over run. So you can count your rise over run, from a graph. But with these, like, the line keeps being too thick and it's hard to do. Okay, but what we should be seeing is that for each additional game that they're playing, it's going down by 2.5. So that is my, slope. So for this answer, what's your slope? The slope is negative 2.5. Now, you would probably be better off seeing your slope and your y-intercept. They do have the correct y-intercept here. You'd probably be better off seeing it from your rearranged equation. So that's why we have you doing that in number 6. So my given equation was in standard form. We went over how to rearrange equations the past few lessons. So if that's still a struggle, like you need to figure it out, you need to ask questions, you need to go to tutoring, you need to pay attention. But you have to be able to rearrange equations because that's how we get things into slope intercept form. Into y equals mx plus b. What's alone in y equals mx plus b? The y. So if I get the y alone, which is what it's asking you to solve for, then I can have it in slope intercept form, and it's easier to see my slope and my y-intercept. So how do I cancel out this 250x? How do I make it go away so that the y can be alone? And whatever you do on one side. And I'm trying to put it more towards this side, not under the y. So then I have y equals, and I just want it to look a little bit more like this. So I'm just gonna put the x term first, which I'm allowed to do because I'm not changing the signs of anything. The 250 is still negative, the 15 is still positive. This is my slope intercept form. So is this, but I just like it to look a little bit more like mx plus b, but same difference. In slope intercept form, you can clearly see your slope, which is always in front of the x, no matter what order it's in. And your y-intercept, you can clearly see. Questions on that? Now, the numbers, the equations will be slightly different based on your equation. But the rearranging steps are still the same, just like how we did before. Undo what's being done, isolate that y. Now we're seeing our slope intercept form. And we can see that now on the graph. I am going to, if you didn't have this equation, I'm going to give you kind of like a key for your equation so that your notes can be correct. But do we have any questions about this process? Okay. You're going to do this next question then as your cool down. So it's on your notes only. Stop talking for the love. So nickels and dimes. Andre's coin jar contains 85 cents. There are no quarters or pennies in the jar. So the jar has all nickels, all dimes, or some of each. You need to write an equation that relates the number of nickels N and the number of dimes V and the amount of money in cents in the coin jar. Graph your equation and answer these questions. How many nickels are in the jar if there are no dimes? How many dimes are in the jar if there are no nickels? I would recommend maybe save the graphing for last. For me, answering 3 and 4 helped me graph, so that's what I would recommend. But this is your check for understanding, your cool down. I'm gonna give you 5 minutes to try it out yourself, and then we're gonna go over the answer. So that doesn't mean pack up at 10:25. Like, no, we need to fully go over it. You need to correct your notes. Before you even put your notes away, you need to finish it. So We have this real world situation we need to make an equation for. What do I tell you to identify that kind of makes it a little easier in making your equation? A total of some sort. What is a total of some sort in this? That's their total amount of cents in the jar. Now, notice our axes. I'm not gonna have like crazy numbers going on. So when I'm representing these 85 cents, I'm gonna use like in dollar form 0.85 rather than equals 85. So I'm doing that, which might change if you did something different. Not saying your equation is necessarily wrong, I just want to be able to graph it on this coordinate plane. To do that, I'm gonna put it in dollar form. Which means that whatever goes over here needs to contribute to these 85 cents and also be in dollar form. What contributes to the 85 cents? Nickels and dimes. How much is a nickel worth? 5 cents. And what is that in dollar form? And for every nickel, it's 5 cents. So what do I need to do? Do I need to do 0.05 plus n? What do I need to do? We're missing our variables. They want us to use n for nickels, d for dimes. It's not just gonna be n plus d is 0.85. I need something that gives me the dollar amounts of each. So what needs to go here? Next to the 0.05. And an n because it's times n, like you can just imply multiplication by not leaving a space. What about the dimes that are contributing to it? Good. So this can be an equation that represents it. If you did it where you didn't put it in dollar amounts, then it might look like this. But I want to be able to graph it, so I'm gonna do it like this. Okay. If there are no nickels in the jar, how can I figure that out? What do I need to plug in a 0 for? The n, if there's no nickels, how many nickels do I have? So then if you plug it in, that lets you solve for how many dimes you have. So then it's 0 plus 0.10d equals 0.85. What is opposite of multiplying by 0.10? And whatever you go on one side. So if I have no nickels, then I would need to have 8.5 dimes. I know I'm going kind of. If I want to figure out how many nickels I would have, what needs to be 0? You can start typing up now, but yeah, you plug in 0 for the D and solve, ends up being 17 nickels. All right, have a good day. See you guys tomorrow. Oh, that's not.